Hi everyone, this is Dr. V.S. Nishok from EC Department, SNS College of Technology. Here we are going to discuss the topic Register Organization in 8051 Microcontroller. The registers are used in the CPU to store information on temporary basis, which could be data to be processed or an address pointing to the data which is to be fetched. The register organization in the AT89C51 includes general purpose registers, special function registers, and bit addressable registers. General purpose register. The 8051 has 32 general purpose registers divided into 4 banks, bank number 0, bank 1, bank 2 and bank 3, each containing 8 registers starting from R0 to R7. By default, bank 0 is used, but the active register bank can be changed by modifying the program status word register. These register banks are present in the internal RAM memory. Register banks in 89C51 microcontroller are used in various situations to enhance efficiency, context switching, and modularity of the code. So here we can see the example for the general purpose register. Okay, so move. We can see the example instruction move R1 comma hash 25H. So that is representing the data 25H will be moved or loaded immediately into the register R1. Okay, similarly the another examples move R2 comma hash 10H and then add a comma R1. So that is nothing but adding the data available inside the register R1 with the data available inside the accumulator and storing the final final value into the accumulator. So here is the example for register banks. So that is 4 banks with each register with the address, that is memory location, represented here. Okay. Special function registers in 89C51 accumulator ports 01, 2, 3 and B register data pointer DPTR program status word PSW and then stack pointer SP. Accumulator. The accumulator register A is used for all arithmetic and logic operations. If the accumulator is not present, then every result of each calculation is to be stored into the main memory. Access to main memory is slower than access to a register like accumulator because the technology used for the large main memory is slower than that used for a register. For example, move a comma has 55H. So that is nothing but we are loading the immediate value 55H into the accumulator. Similarly, B register. B register is very similar to the accumulator in the sense that it may hold an 8-bit value. The B register is used only by two 8051 instructions multiply, so that is MUL A B and divide DIV AB. To quickly and easily multiply or divide A by another number, you may store the other number in B and make use of these two instructions. Apart from using MUL and DIV instructions, the B register is often used as yet another temporary storage register, much like a 9 R register. Data pointer DPTR is the 8051's only user accessible 16-bit register. The accumulator R0 to R7 registers and B register are 1-byte value registers. DPTR is meant for pointing of data. It is used by the 8051 microcontroller to access external memory using address indicated by DPTR. DPTR is the only 16-bit register available and is often used to store 2-byte value. So in order to access the external memory, we will be using the DPTR in our instruction. The example instructions are given at the last. That is move DPTR comma hash 1234H. So that will load the address 1234H into DPTR. Coming to the stack pointer SP. It is a 8-bit register used to indicate the current top of the stack in the internal RAM. The stack is a section of memory used for temporary usage of data and return addresses during function calls and interrupt handling. On reset, the stack pointer is initialized to address 07H. This means the stack starts just above the register banks. So, given examples for stack pointer are nothing but push operation and pop operation. Next, coming to the bit addressable register. Certain special function registers and RAM locations are bit addressable, allowing individual bits to be set or cleared. This feature is useful for bit level operations. Example include PSW, P0, P1, P2, P3 port registers, TCON, SCON, IE and IP registers. Use cases. Port control. The individual bits of the port registers can be accessed to control individual pins of the microcontroller. Set B, P1.0. So this is the example instructions relevant to the bit addressable register. So that is, each individual bit can be utilized for a separate purpose. So that is shown here in this slide. Okay. Coming to the conclusion, so here we can summarize the topic register mapping. So here we are having different registers: general purpose register, special function register and bit addressable registers. So we have seen of each and every register in detail, and we have came to the assessment section. Here we can recap the topic register mapping with the questions: what are the registers in 89C51 microcontroller, and name any two devices in school or home that use microcontroller. So these are the two assessment questions relevant to this today's topic, register mapping or register organization in 89C51 microcontroller. So we can see the next topic in the forthcoming video. Thank you for joining this video. Thank you.